And good morning, fourth grade students. Welcome to Eureka Math. Eureka, when translated to the English language from the Latin language, it means I found it. And what have we found? We found the best way ever to learn new math concepts. Today, we will continue our transition. We're transitioning. We're moving ahead from four partial products to the standard algorithm for two-digit by two-digit multiplication. So that's what we're going to be doing today. Let's start by multiplying by multiples of 10. That's our fluency practice. So let's write 67 times 20. And we'll say, well, you know what? Let's flip that. Let's go 20 times 67. We're going to do two tens. That's 20 times 7 ones plus two tens times 6 tens. You got that? Let's think about how we're going to do this. Well, I know that two tens times 7 ones, two tens times 7 ones, is going to equal what? Well, where I come from, that would equal 2 times 7 is 14, 10 times 1, 10. So 14 tens. Oh, hello, Mr. Kim. So then our other problem is we're going to take the two tens times 6 tens. So that'll equal 2 times 6 is 12, and 10 times 10 is hundredths, right? So what we have is 14 tens and 12 hundredths. So 14 tens is 140, and 12 hundredths is 1,200. And then we just add those up together. We get 0, 4, 3, and 1. Let's try another one. And that's 20 times 78. The first thing we're going to do is take two tens and multiply by 8 ones. So think about that. Two tens times 8 ones. What will that equal? The second thing we're going to do is do two tens times 7 tens. Two tens times 7 tens. So what will that equal? Two tens times 8 ones. 2 times 8 is 16. 10 times 1 is 10. So we get 16 tens. 2 times 7 is 14. 10 times 10 is 100. So we're going to have hundredths. So what do we have here? We have 16 tens, which is 160. Then we have 14 hundredths, which is 1,400. Add them up, 0, 6, 5, and 1, 1,560. Would you like to try one on your own? I bet you would. So, I'll offer a little coaching. We'll do 30 times 45, and think about it as 3 tens times 5 ones, and 3 tens times 4 tens. And go ahead and pause the video and do your best to finish this up on your own. Pause the video. And welcome back. What answer did you get? Well, let's take a look. We have 3 tens times 5 ones. 3 times 5 we know is 5, 10, 15. So we have 15, 10 times 1 is 10, tens, and then 3 tens times 4 tens, 3 times 4 is 12, and we have 10 times 10 hundredths, right? So we have 15 tens, that's 150, plus 12 hundredths, 1,200. Hopefully I'm in the frame here, it looks like I am. And we add it up, 0, 5, 3, and 1. So you've got 1,350, you got the right answer. Let's move on to the problem of the application variety, as I like to call it, or the application problem, as others like to call it. Right there, looks good. Let's find out what's going on here. Find out what we know. What do we know? Sandy's garden has 42 plants in each row. That's something we do know. I'm going to circle that number 42 because I bet it comes into play. Just guess it. She has 2 rows of yellow corn and 20 rows of white corn. I'm going to circle 2 and 20. So now, my task, this is what I know, 42 plants in each row, 2 rows of yellow corn, 2 rows of white corn. says draw an area model representing two partial products to show how much yellow corn and white corn has been planted in Sandy's delightful garden of corn. Reminds me of that story Scarecrow Joe some of you read yesterday. So let's get busy with this. We're going to start with an area model. I'm going to draw it over here. And area model, a model of the area variety. But we're going to do that, not the 4-section one. We're just doing the 2-section one, all right? Because we are so on top of this. So we have the 22 rows of corn. We have 20 white and 2 yellow. And then we also had 42 plants in each row. What we're trying to find out is how much yellow and white corn and white corn has been planted. So let's get started on it right away. I'm going to go over here and do my standard algorithm of 42 times 22. See how that all works? Let's think about it. 2 times 2 is 4, and 4 times 2 is 8. So 2 times 42 equals 84, right? Now, as we're looking at this, hi. Let's take a look at this a little bit more, a little bit further detail, and get to 20 times 42. Remember, say goodbye to that guy. We're done with it. I can put a 0 here because I'm multiplying by 10. It's by 20, actually. So 2 times 2 is 4. This reminds me of some of the problems we did yesterday, and 4 times 2 is 8. So we can see that 42 times 2 is 84, and 42 times 20 is 840. Then we just add them up. 4, 8 plus 4, 8, 9, 10, 11, 12, and there we have it, 924. So we're not going to bother right now that she has 924. We're just going to take it for granted that we know that. All right, time for the development of the concept variety, or the concept development, as some people call it. And let's get busy on that. Doing something new, folks. Doing something a little bit new. Okay? Let's take a look back at our problem our application problem, and we can see. Let's make a new drawing. Why not? So we saw that it was 42 plants in each row, and there were 20 of the yellow and 2 of the white. No, 20 of the white and 2 of the yellow. And we saw, as we look back at this, was 42 times 2, or 2 times 42, and then 20 times 42. That's what this area model represented, okay? Now we're going to put our standard algorithm over here, 42 times 22, right? And we had 84, right, as our first number, and 84 equaled 2 times 42 equaled 84. And then we had 840, and that equaled what? 20 times 42. So it equaled in total, as we've already done this problem, 924. So we can see how this breaks down. Let's do another problem. We're going to go to another piece of scratch paper. And we're just going to go straight ahead. 62 times 29, all right? So the first thing we're doing is we're going to do 9 ones times 2 ones. What's 9 ones times 2 ones? It's 18 ones, right? 9 times 2 is 18. So this is how we're going to kind of approach this, okay? Going to go like this. This is the Eureka way. So 18 ones, right? So that's 8 ones and 1 10. All right? Now, we're going to do 60 times 9. Okay, 60 times 9. Think about 60 times 9. What would you equal? What would that equal? Well, 6 times 9 is 54, right? But we're dealing with tens, right? Because it's 60 times 9, so it's 54. But because we're dealing with tens, how many zeros am I going to add onto that? Just 1, okay? So it'd be 540. But I have this other 10 to deal with. So we're going to add that 10 onto it. And of course we get 550. So I'm going to cross that out, but I don't need to put 550. All I need to do is put the 55, the 550, because we already have a number in our ones place value, okay? Now it's time to tackle the 62 times 2 tens, or 62 times 20. I can eliminate that 9 now. We're not going to be dealing with that anymore, okay? But because we're dealing in tens, I have to put a 0 here, because we're doing 62 times 2 tens, all right? If I didn't put it there, we wouldn't get the right answer, because it would just be 62 times 2. But we're doing 62 times 20, so I'm putting a 0 right there. Now, 2 times 2, or in this case 2 times 20, would be 40, right? So there's my 4. Look at that, 40, huh? Isn't that amazing? And then 60 times 2, 60 times 20, excuse me. 6 times 2 is 12, but there's 2 zeros in 60 times 20, so that'd be 1,200. But we just go like this, 1,200, because we already have numbers in those place values. And there we have it. So we can see that this is 9 times 62, and this is 20 times 62. Now we're ready to add 8, 9, 7, and 1. Okay? We're going to keep doing a few more of these. I'm going to scroll up a little bit. And we're going to solve 46 times 63. You know what? I'm going to put the larger number on top. Always a little easier. Now, let's think about it. The first number in this problem, are we there? Yeah. The first number in this problem, the first step in this problem is 63 times 6, okay? So 6 times 63. That's what we're focused on first. What could 6 times 63 be? Well, 3 times 6 are 3 ones times 6 ones is 18 ones, right? 3 times 6 is 18 ones. There's my 10, there's my ones. 1, 10, 8 ones. Now, 60 times 6. Well, I know 6 times 6 is 36, or in this case, 360, because it's 60 times 6, but we got to add that 10, so it's 370. But I don't need to put the 0 there because I already have the 8 in the ones place, so it's 378. Now, down below, the next step, we're going to do 40 times 63, okay? We're done with this 6. Done. But in place of this 6, it becomes a 40 now. I'm multiplying by tens, so I'm putting a 0 there, okay? Now, on this number, I'm doing 3 times 40, okay? 3 times 40, and 60 times 40, okay? So 40 times 63. How am I going to go about doing this? Well, oops, almost lost some power there with that wind. Oop. I'm glad my camera's on battery. Might not matter. Well, I know that 3 times 4 is 12, right? But in this case, it's 3 times 40. So that's 120. Here's my 20. There's my 100. 3 times 40 is 120. Now I have to do the 60 times 40. 60 times 40. Think about it. 6 times 4 is 24, but it's times 60 times 40. That's 2 zeros, so we're in the hundreds. So 60 times 40 would be 2,400. But all I need to put is the 2,400 because I have a digit in my tens place and a digit in my ones place. Now it's time to add it all up. We get 8, 7 plus 2 is 9, 3 plus 4 is 7, and then we bring down the 2. Before we dig into our problem set, let's do one more. And I want you to try to do this one on your own, okay? We're going to have, let's do 72 times 31, all right? And I want you to try to do this on your own. Think of it as 72 times 1 and then 72 times 30. In fact, let's go ahead and do that right here. 1 times 72 and 30 times 72, okay? Do your best. Hit pause. Pause. Hit pause. It reminds me of the joke about the three-legged dog that walks into an Old West saloon and says, I'm looking for the man that shot my paw. Okay, welcome back. I hope you tried your best on this problem. I hope you're not just waiting around for me to finish it, because that would be counterproductive. So, 72 times 1. We already know the answer, don't we? Multiply something by 1, it remains the same. 2 times 1 is 2, 7 times 1 is 7, so we can cross that out. But now I'm multiplying 72 by 30. Because it's 30, I need to put a 0 here. Because look, 30 times 2 is what? Well, 3 times 2 is 6. We'll multiply them in tens, we'll throw in the 0, so it's 60. Look at how amazing that is. And then we don't need to bring anything over. We just do 7 times 3, 21. My kid always said that. And then time to add. 2, 7, 8, 9, 10, 11, 12, 13. 1 plus 1 is 2. And there we have it. 2,232. Okay, time for a loose problem set. So let's get ready for the problem set. Problem set. Problem. Are we ready to do the problem set? Let me see if I'm in the zone here. Zoom in a little bit because the writing's so tiny. Okay, if you think you've got this down, go ahead and push ahead, full steam ahead, and then come back and check your answers. Always good to check. And then, if you're a little confused, stick around and I'll help you out. So we're getting on page 113. Today's date is 02/11/2020. Okay, here we go. First thing we're going to do is express 23 times 54 as two partial products using the distributive property and solve. Okay, breaking away a little bit from what we were doing in our concept development, but not really. So it's 23 times 54, all right? So we're doing 3 54s plus 20 54s. Okay? 3 54s plus 20 54s. So over here, we would say it's 3 times 54 and 20 times 54. All right? So let's look at 3 times 54 first. 4 times 3. Well, I hope you would say that's 12. There's my 2 1s, and there's my 110. Now I'm ready to multiply the 50 times the 3. 5 times 3 is 15, plus that one is 16, but it's actually 50 times 3 is 150, plus that 10 is 160. So I'm going to put 1 6 there. I don't need to put the 0 because I've already got a 2 in the place value. So now I've figured out 3 times 54, and I can come over here and say, well, 3 times 54 is 162. Now, let's go over here. I need to put down a 0 because I'm multiplying by 10, right? I'm doing 54 times 20. All right, let's get started. 4 times 20. Well, think about 4 times 2 is 8, so 4 times 20, or 4 times 2 10s, is 8 10s, or 80. Look how nicely that worked out. Then we could say 5 times 2 10s. Well, excuse me, 50 times 2 10s. So you have 50 times 20, 20 times 54. In this case, we're left with 50 times 20. Well, I know 5 times 2 is 10, and I'm going to put on 2 zeros, right? So I already have the zeros there, the 8 and 0, so I just put 10 right there. 5 times 2 is 10. In this case, 50 times 20 is 1,000. And the 4 times 20 was 80, so there we have it. And over here, I'm going to put 1,080. Time to add it up. 2, 8, 9, 10, 11, 12, 13, 14. 1 plus 1 is 2. And there's our answer, 1,242. All right? Now, we go down to our next problem. We're going to express 46 times 54 as two partial products using the distributive property and then solve, okay? So let's take a look at what we got going here. And we're going to add a new step to this one, okay? So we have 46 times 54. That means we have 6 54s plus 40 54s, okay? Over here, 6 times 54 and 40 times 54. Okay, we in there? Let me just check my camera. Whoops. Are we all there? We're getting this all in? Yeah, we are. We can scooch over. Nope, the other way. Excuse me. There we go. Right there. All right, so we have this problem all set up now. So let's think about 54 times 6. And if some of you are a little confused still, just go ahead and do it like this way. 54 times 6, okay? Just solve it this way. 4 times 6 is 24. Bring up the 2, 24. 5 times 6, or 50 times 60 is 300. Or 5 times 6 is 30, but add the 2, we get 2, which is 32, or 320. And there's our first answer. So 6 times 54 is 324. And now we're going to do 54 times 20. Excuse me, times 40. 54 times 40. We did 54 times 6, and now 54 times 40. I'm going to put the 0 right here, because I'm multiplying by tens. 4 times 40. 4 times 40 is 160. So there's my 6. There's my 100. Now I'm left with 50 times 40. That's 20. 2 zeros. We're dealing in hundreds. 10 times 10 is 100. So it's 20 hundredths. But now 21 hundredths, because that little guy, and 21 hundredths equals 2,100. So our answer there is 2,160. And it's time to add it up. 4, 8, 4, and 2. 2,484. Let's do another one. And it's saying express 54 times 47 as two partial products using the distributive property and then solve. Okay, let's set up our problem first using the area model. 55 times 47, okay? 55 times 47. So I'm going to put 55 times 47, all right? Over here, it's just going to equal 5 times 47 plus 50 times 47. I hope that you're catching on to this. And I'm going to put this over here too. 5 times 47 plus 50 times 47, okay? Now it's time to multiply, and I'll do it in this area right here. We'll do it a couple of different ways. 47 times 5. Well, now 7 ones times 5 ones is 35. And 40 times 5. Well, 4 times 5 is 20, but this is in the tens realm, right? 40 times 5. So it's 200, but plus that other 3 tens, it'd be 23. So we put 235 here. Well, now I know 235 goes right here. And let's go over here. Let's do it the standard algorithm way. 7 times 5 is 35. Bring up the 3. 4 times 5 is 20, or 200 in this case, plus the 3 tens will be 230. And we're done with that 5. Okay? Now we just have to deal with 50 times 47. So 50, I'm going to put the 50 on top, times 47. Think about this problem. Okay, we're going to do, excuse me. Yeah, 50 times 47. That's really good. Now, you know what? I'm going to be consistent. We'll do 47 times 50. So I'm going to put a 0 here to show that we're dealing in tens, right? 7 times 5, or in this case 7 times 50 is 350. There's my 50. There's my 300. 40 times 50. Well, 4 times 5 is 20, but we're dealing in tens. 10 times 10 is 100. So it's 20 hundredths plus this 300 would make it 23 hundredths. And there's our answer there. Let's go over here and do it this old school way. Bring down the 0 or the standard algorithm. 7 times 5, 35. Bring up the 3. 4 times 5 is 20, plus that 3 is 23. And we have 5, 8, 5, and 2. So we get the same answer all the way across. 2,585, that's 2,585. And this plus this is 2,585. Turn the paper over. And it says solve following using the two partial products, okay? Two partial products. I'm going to get out a big thick pen. Show us a little easier sight here. So we have 58 times 45. Well, basically, what we're doing is brain freeze, 5 times 58 and 40 times 58. See how that works? 45 times 58. Okay, let's go ahead and tackle this problem. And we could do 58 times 5 and 58 times 40. All right, ready to tackle these? Okay, 8 times 5, 8 times 5 ones is 40. There's my 0, there's my 4 tens. 5 tens times 5 ones is 250, plus my 4 tens would make it 6, 7, 8, 9, 290. So I have an answer now over here for 5 times 58 is 290. Okay, let's go over to 58 times 40. I'm dealing in tens, so I'm going to put a 0 there. Okay. 8 times 40, 8 times 4 is 32, but since we're dealing with tens, that'd be 32 tens or 320. Look how that 0 is right there for me. Okay, it worked out quite nicely. So, excuse me, I'm just like, it's a little tired this morning. I'm going to keep my 20 there. So it's 320. I'm putting my 3 right there. 320. Now we do 50 times 40. Well, 5 times 4 is 20. But since we're dealing in 10 times 10s, it would be 20 hundredths. We add on these 3 hundredths, that makes it 23 hundredths. So there's our answer for that, 2,320. Okay, now we just add them up together. 0, 9, 10, 11, 3, 4, 5, and 6. So our answer is 2,610. Okay, let's head on over here. Our next one. So solve using multiplication algorithm. So it's just a straight ahead algorithm. Are you ready for this? I hope so. We're doing 5 times 82 and 50 times 82. Okay? So now let's get started on this. We're going to do 2 ones times 5 ones is 10. So I'm going to put a 0 and a 1 there. 8 tens times 5 ones. Well, 8 times 5 is 40, so it's 40 tens, or 400, plus that 1 10 makes it 41. Okay, now we're done with that 5. Now we're doing 82 times 50. Well, since I'm dealing in the tens, I'm going to put a 0 right there. 2 times 5 is 10. All right, in this case, 2 times 50 is 100. There's my 0, there's my 100. Now I'm just stuck with 8 times 5 or 80 times 50. Well, 8 times 5 is 40, right? So that's 40 tens plus this 1 10 is 41 tens. Excuse me, 41 hundredths, so it's 4,100. And we're ready to add 0, 1, 5, and 4. All right? So we're going to do the same thing over here with these two problems. Just setting out and doing the standard algorithm, okay? 63, I like to put in the larger number on top, times 53. And 84 times 73. Just the way my brain works, in fact, like most people. So it's 3 times 3. 3 ones times 3 ones is 9. 60 times 3. In this case, it's 60 times 3. 6 times 3 is 18. Be 180. Our 18 tens. There's our 18 tens. We're done with that 3. Let's put a 0 right here because we're dealing in tens now. 3 times 50. Well, 5 times 3 is 15, so this must be 15 tens. 6 times 5, this is actually 60 times 50, so that must be 30 hundredths, plus that 100 there makes it 3,100. And then we add it up. 9, 13, 3,339. I'm going to continue on here. 4 times 3, 12, so that's 2 ones and 1 10. 80 times 3, well, 8 times 3 is 24, so it's 240 plus that 1 would make it 250 plus that 10. Done with that 10, done with that 3. bring down to 0 because we're multiplying by tens now. See? So 4 times 7 is 28, but it's actually 4 times 70, which would make it 280. There's my 80, and I'm going to put my 2 right over here where I won't forget it. 8 times 7, 80 times 7 is 5600ths, or 5,600. We add on those two, 57, 58. Add it all up. 2, 8, 9, 10, 11, 12, 13. 8, 9, 10, 11. Bring up the 1. 6,132. So please put this in your binder to help you with your homework tonight. We're doing both pages, all problems. Practice will make perfect when we're talking about multiplication standard algorithm. Oh, I didn't have any characters come by today. Oh well, maybe next time. Go ahead and log on to Cool Math for 10 minutes. Take a little break.